Every so often, part of the sun's atmosphere erupts, sending 1 billion tons of electrified gas into space. This isn't usually a problem, but sometimes it's pointed at Earth, and this can cause some trouble. You see, when charged particles from the sun hit Earth's magnetic field, it can cause a process known as magnetic reconnection. We call it this because if you look at the magnetic field lines, it looks like they're breaking and reconnecting. Now, this process isn't harmful to humans, but it can cause more current to run through our electronics than they'd expect, which can be incredibly damaging. Now, I want you to think for a second about all the things in your life that depend on electricity. Airplanes, GPS, the power grid. All of these things can be damaged by the effects of magnetic reconnection. Just like we use weather forecasts to protect ourselves from extreme weather on Earth, we want to be able to predict our space weather too. But this is where our problems begin. If you remember learning about the scientific method in school, you probably remember learning about the hypothesis, the guess you make about how your experiment is going to go. The reason why we make this guess is to test our understanding of the world. If your hypothesis is correct, it means you're probably on the right track. And if it's not, it means there's something you don't understand yet. It means that there's something to discover. Scientists in my field have used their best understanding of electricity, magnetism, and charged particles to try to predict the rate at which magnetic reconnection occurs. And these guesses are wrong, which means there's something here to discover. But if finding this new physics was easy, we would have done it by now. Our satellites and telescopes provide invaluable measurements, but they only get one chance to study each reconnection event, and they're either incredibly zoomed out or stuck in a specific place at a specific time. And we need a more complete picture to find the physics that we're missing. This is where my research comes in. Right here at UCLA, we have a machine known as the Large Plasma Device, which allows us to recreate astrophysical conditions right here on Earth. There are two main ingredients to our setup: a dipole, or a mini-Earth, and incoming charged particles, like the particles that come from the sun. We create these particles by exploding part of a carbon block with an extremely powerful laser. But what makes my research unique isn't the laser or the fact that we can see magnetic reconnection in the lab. It's the fact that we can recreate the same reconnection event thousands of times. We can study this phenomenon up close from every angle. My research is to collect and analyze this data to help us look for the physics that we're missing. My project can help us protect the vital parts of our world that depend on electricity. And, maybe even more exciting, it can help us understand part of the world that we never have before.